Welcome. So now we're going to learn how to solve right triangles, which means we're going to find all of the unknown sides and angles in the right triangle. And I wanted to go over first the techniques that we can use when we're solving right triangles. So first we want to find any missing sides. And to find the missing sides, we have two techniques. Technique number one, and this is, by the way, solving right triangles only. So technique number one, of course, is Pythagorean theorem. You'll use Pythagorean theorem if you know two sides. Our other technique is a trig ratio. We'll use a trig ratio if we know one side and one angle. Right, so now let's talk about what about finding missing angles? What are our techniques to find missing angles? Well, we have two techniques here as well. Technique is one that we learned a long time ago, and that is triangle sum theorem. And as a reminder, triangle sum theorem says that the angles in a triangle add to 180 degrees. We'll use triangle sum theorem if we know two angles. And then we learned a second technique, which was inverse trig ratios, where we're going the other way with our trig ratio. We know the ratio, we have the two sides, now we're looking for the angle. So here, we're going to use an inverse trig ratio if we only know the right angle. We have to know the right angle, otherwise we wouldn't know we could use trig ratios or inverse trig ratios. So these are our four techniques that we're going to use, and which technique depends on what we know and what we still need to find in the right triangle. Right, so let's look at the first one. All right, so here we have two sides of the right triangle. When you know two sides of a right triangle, use Pythagorean theorem to find the third side. Pythagorean theorem will be exact. Our trig ratios are always a bit approximated, right, for the most part, and so we might have some rounding error if we use a trig ratio. And there's no reason, and we couldn't use a trig ratio anyway because we don't know any angle measures. So we definitely would not be able to use a trig ratio. We don't know any angle measures. And once we solve for an angle, we wouldn't want to use that angle because then it'll introduce rounding error. So of course we want to use Pythagorean theorem. All right, so here's our missing sides. And I believe most of these problems are in your notes. All right, so to find the missing side, we use Pythagorean theorem. We were missing the hypotenuse. So let's just call that x, I guess. So we have x squared equals 5 squared plus 12 squared. 5 squared is 25, 12 squared is 144. Now you might recognize, if I add 25 and 144 together, that's 169. You might have recognized that this was a Pythagorean triple. And if you recognize that this is a Pythagorean triple, then you are fine to just write in x equals 13. So this one did happen to be a Pythagorean triple. A triangle, right triangle, whose sides are all integer values. It's called a Pythagorean triple. And we had a near pot on that you did independently. All right, so we found the missing side. That was no big deal, right? Now let's find the missing angle. All right, so we're going to solve for both angles there. We have theta in that angle. We'll just call this one angle B there. All right, so let's solve for theta first. All right, so now we could technically use 13, the hypotenuse. That is an exact answer. It wasn't rounded. But what if we made a mistake? I mean, what if you thought the square root of 169 was something else, right? So you're best off with just sticking with the sides that you already know, because you know those are correct, right? There's no possibility there's a mistake there. So now let's identify our sides relative to theta. We're going to find angle theta first, right? And this is the opposite side, and 5 is the adjacent side. All right, so we needed to figure out the trig ratio that uses opposite and adjacent. And so we've got opposite and adjacent. And I hope you are thinking tangent. All right, so we have tangent theta equals, tangent is opposite over adjacent, so it's going to be 12 divided by 5. To isolate your variable, take an arctan of both sides. Right, so arctan and tan cancel each other out. That's theta equals, and then we have arctan of 12 fifths. And in this Nearpod, in this video, we are going to use the calculator to evaluate. All right, so I'm going to plug, as soon as I get the calculator out, I'm going to plug that into the calculator. First, I have to find my cursor. Otherwise, I can't find my calculator. All right, so we have 12 bits. So 12 divided by 5 equals, right? And then we're going to hit the inverse to get arctan, and that is a 67.38 degree angle. Actually, I think we did one like this in another lesson, but 67.38. Now you could use a trig ratio again to get the next angle, but we do have another technique, and I think maybe you'll find this one easier. Now you can use a trig ratio again, that is okay. All right, so we want to find B there. We can either use a inverse trig ratio, or we could use triangle sum theorem. And the reason we can use triangle sum theorem is that we're not really going to have rounding error because we have a limit, right? We have a limit of 180 degrees. So it's not like we're computing with a rounded value. We're subtracting what's left. It's not going to create any rounding error. The only way that we would make a mistake, however, is if 67.38 were incorrect, well, then our next answer is going to be incorrect as well. But I think it is totally fine to just use triangle sum theorem. Students really just don't make that many errors, and it's easy enough to use triangle sum theorem, right? Otherwise, you can use arctan again, right? Because we could go the other direction, and then 5 would be the opposite and 12 would be the adjacent. But I'm just going to use triangle sum theorem, right? So angle B here is just 180 degrees minus the other two angles, which is 90 plus 67.38. Which means that angle B is 180 minus 157.38. So that means that angle B equals 20. I always have a hard time subtracting in my head with decimals. 22.62. I'm just making sure. Yes, 22.62. And I remember actually that answer after I wrote it down. So if you remember, we did one a long time ago, And we got that exact same answer, 22.62 degrees. So, and we used inverse trig ratios. So you have to use inverse trig ratios to find the first angle, but you can use either inverse trig ratios or triangle sum theorem to find the second one. Right? So now here's our first one, and I've written all the steps as well as some little helpful hints. I'm not going to write all of these things each time, like use Pythagorean theorem to find the third side if we know 2. We'll just remember that. I won't always use inverse trig ratio or triangle sum theorem each time, right? But I'll write some helpful hints on each slide so that you're able to follow along, right? And that'll help you in your notes as well. I think that almost all of these are in your notes, and I'm pretty sure this one is. And I'm sure this one is as well. So we want to find the lengths of DE, FD, and angle F in triangle DEF. All right, so here we only know 2 sides, right? So we could not use Pythagorean theorem. We're going to have to use trig ratios to find the 2 sides. And we will not use Pythagorean theorem with a value we have solved for ourselves using trig ratios. That will create rounding error. It's not like triangle sum theorem where we have a limit of 180 degrees. All right, so that one's X. Let's just call this one Y. All right, so angle relative to angle E, we have the opposite. Y is the opposite. And D, opposite the right angle, 7.6 is the hypotenuse. So we're going to, first of all, use trig ratios to find the missing sides. All right, so let's solve for y first because I labeled y, so we may as well start with y. All right, so y is the opposite, right? Who uses opposite and hypotenuse, right? That would be sine, right? So we have sine 40 equals y divided by 7.6, right? We would use sine because we have the opposite. We're looking for the opposite and we know the hypotenuse. I'll put the little reminders there. All right, so we want to isolate y. We're going to multiply both sides by 7.6. So we have 7.6 sine 40 equals y times 7.6 times 7.6. That'll cancel out. And so we have 7.6 sine 40 equals y. Let's plug that into the calculator. Right, so I'm going to clear that from the last problem. And so we have 40. Oh, I also have to get rid of that. 40 sine and then times 7.6. So we get we'll round to 2 decimal places, I guess. Actually, we could do 3, 4.85 or 4.89, whichever you prefer. I guess we'll do 2 decimal places, 4.89. All right, so we found 1. Let's find the other missing side. All right, so relative, and I always just stick to the angle we're given. Relative to that angle, the other unknown side is the adjacent side. All right, so who uses adjacent and hypotenuse? Well, that would be cosine. So we have cosine 40 equals x divided by 7.6. And we're using cosine because we're looking for the adjacent and we know the hypotenuse. And this is going to be very similar to the last problem. We're going to multiply both sides by 7.6. That'll cancel. So we have 7.6 cosine 40 equals x. And now we'll just plug that into a calculator, and then we'll have that one as well. Somehow I took up less space on that one. I think I wrote smaller. Oops. Going right past the calculator. All right, so we have 40 cosine times 7.6. And that is 5.82. And there we go. We have found the two sides using trig ratios. All right, now let's find our missing angle. And if we know two angles of a triangle, the easiest thing to do is find the missing angle using triangle sum theorem. So this will be looking for angle F. So angle F is equal to 180, right? Because all together the angles all add up to 180. We'll subtract the two known angles, which is the right angle and that 40-degree angle. So that is 180 minus 130. So angle F equals 50 degrees. And it is fine for triangle sum theorem. If you look at that and you go, okay, well 90 and 40, okay, I need 50 more degrees. And you can do that in your head, that's fine. All right? You don't have to show your steps for triangle sum theorem. I trust that you can subtract, right? But do show your steps for solving with Pythagorean theorem if it's not a Pythagorean triple, for solving with trig ratios, right? And solving for angles using inverse trig ratios. For those you need to show your work for. I'm fine if you wrote angle F is 50 degrees and didn't show me how you got it. I'm okay with that. All right, I think I'm going to do one more on this podcast. I'm going to split it probably into two podcasts. We want to solve for triangle ABC. When it says solve the triangle, it means we need to find all unknown sides and angles. Right? So we only have one side and one angle. Right? So we're going to use trig ratios to solve for the missing sides, and then we'll use triangle sum theorem to solve for the missing angle. Right? So before you get started, always identify how the sides relate to the given angle. Decide which trig ratio to use. I guess we'll go alphabetical and solve for A. Right? So A is the opposite side from angle A. It's across the triangle. And we know sides are named for the angles opposite them. So of course side A is opposite angle A. And then B is the adjacent side. Right? So opposite and adjacent, that is tangent. Right? So if we have or are looking for opposite and adjacent, then we're going to use tangent. I'm just going to put that over there as a little reminder for us. All right, so tangent A equals A divided by 15. Right, and now I just got to multiply both sides by, oh, excuse me. I should probably substitute the value of the angle in there. Otherwise, we're going to be quite stuck. Tangent 28, which is angle A, is equal to side A, the opposite side, over side B, the adjacent side. Multiply both sides by 15. We have 15 tangent 28 equals A divided by 15 times 15. That cancels. So we have 15 tangent 28 equals A. So now we can just use the calculator and we'll get the value for A. And then we're going to do the same thing. We're going to solve for B using the trig ratio. Right, so let's clear that out. So we have 28 tangent times 15, and that is that's going to keep running, 7.98. That'll round up. Yep. Never likes to write in the beginning when I switch. All right, so now let's find the side C. That is opposite the right angle, so that's the hypotenuse. So we should not use 7.98. That's not the exact answer. I rounded. Right? I rounded to 2 decimal places. Let us use the known adjacent side. So who uses adjacent and hypotenuse? Well, of course, that is cosine. All right, so we have cosine 28 equals, the adjacent side is 15, the hypotenuse is c. So now we need to get the c out of the denominator, so we're going to multiply both sides by c. Those cancel, so we have c cosine 28 equals 15. All right, and now we still haven't isolated our variable. We have to divide both sides by cosine 28. So now we have c equals 15 divided by cosine 28. And now we can plug this into a calculator and find out what that value is. So I have 15 divided by parentheses, and that was 28, 28 cosine, close parentheses, because this is the backwards calculator, and that equals 16 that's going to round up, 16.99. If we wanted 3 decimal places, that would be 16.989. So 16.99. All right, so we have finished finding the two sides. Let me just double check that number. Yeah. And now let's find the missing angle, which is really easy. It's the third angle. So use triangle sum theorem to find the third angle. So we have angle B, is the one we're missing, is equal to 180 minus, the other two angles are 90 plus 28. So that is 180 minus 118. That means angle B is 62 degrees. Right? And that's all there is to it. So really, we've already solved for missing sides using tangent. We've already solved for missing sides using cosine. We've used triangle sum theorem before. We're just putting it all together. Right? That's all. Right, so in the next video, we're going to solve some more. And we're going to solve when you're not given a triangle. How do you set that up and find those missing values? All right, so thanks for watching, and bye for now.